Mike Walton on components.
Okay, so first of all, we're just going to have a little discussion about what a PCB is, so we can properly understand the difference between a through-hole and a surface-mounted component. As you know, this lovely little green thing here doesn't have to be green, it can be any colour you want, but it's a typical example of a PCB. Now we have 1 layer, 2 layer, 4 layers, or as many layers as the production plant can do for us, as to how complicated that PCB comes. What do I mean by that? If we can imagine that this is my PCB, that is the worst pen ever.
We can imagine a pen working as well, Mike.
Okay, if we can imagine that this is a PCB, yeah? If I have a 1-layer PCB, what it basically means is this top layer here, yeah, this is the top, and this is the bottom. It means that this top layer here, I can place my components and solder them. But there's no soldering ability on the bottom layer. So there's nothing I can do with the bottom layer. It's a 1-layer board, it's the cheapest way to produce a PCB. The second option is a 2-layer board. And all it is it means there's a copper layer on the top and a copper layer on the bottom. So I can solder both on the top and on the bottom. So I've doubled my real estate, if you like. I've doubled the amount of places that I can put solders and pins. Because the big problem with a PCB is if I have something like this and a resistor here, yeah, for example, sometimes I need to get a wire and there's another resistor here doing something. Sometimes I need to get a wire through here, but I can't, there's not enough room. So what do? Well, then I can get a 2-layer board and I can drop that track through to the other layer, pipe it under the other layer and come up again, can't I? Yeah, so it gives me more real estate. Now, what actually is in the build-up of a PCB? What we can do is we can have a look at that. In the middle of this PCB is a fiberglass PCB, it's called FR4, that's the material, standard size 1.6 millimeters thick. They can go smaller, but the production cost goes up. So if we can imagine, in the middle of this, I've got a piece of fiberglass, we call it a pre-peg. It's an insulation layer, yeah? And then on top of that pre-peg, I have a copper layer. Yeah, so if it's a 2-layer board, I'll have a copper layer here and a copper layer here. Yeah? On top of that copper layer, I have a solder mask layer, which is what you see the green print that's going over here. So I'll have a solder mask layer that sits on top of there, and a solder mask layer that sits on top of here. So we have pre-peg, yeah, we have copper, I'll just call it CP, we have copper here, and then we have a solder mask, and a solder mask. What the solder mask does is it stops your solder from flowing from one place to another place where you don't want it to flow. Yeah, it stops the flow of solder because solder will always flow towards heat. On top of that, and this is the last layer, you can see I have words, don't I? That's what we call the overlay or the ident layer. And that gets printed on the top of this. So when you were looking at your, I'll call it an OL for overlay. So when you're looking at all your layers in Multisim, now you understand. If I wanted to draw a track on my top layer, I need to tell Multisim, okay, this line I'm drawing, I want it to be on the top layer. That's why I need to select the top layer in the Multisim. Yeah, so I'm telling it where I want to place this line. Am I going to place it on this copper layer or this copper layer? Ultimately what happens is this piece of FR4 in the middle with the 2 bare copper layers gets put through a production facility, and they use ultraviolet to be able to etch onto that copper, to be able to burn it in the places where you don't want acid to dissolve it. Yeah? And then they will dissolve the entire board in acid, and it will take away the copper which hasn't been protected. After that's done, they'll spray it with this solder mask to stop the copper from oxidizing and to stop your solder from flowing. So that's the basics of a 2-layer board. If we just very quickly discuss a 4-layer board, what actually happens is you have all this, but in the middle, right, if I did a little explosion here, you would have another piece of pre-peg, yeah? So I'd have a top layer here, a piece of pre-peg, a hidden layer, hidden copper layer, another piece of pre-peg, another hidden layer, a final piece of pre-peg, and then the bottom copper layer. So I've got 2 hidden bits of copper in the middle, and they're all manufactured independently, stuck on top of each other, and then a 100-ton press presses them all together to make the PCB, and then it all gets drilled together. Yeah? So I can now pass a via or a connection between this layer down to this layer, which is called a blind via. I could get a via from this inner layer to this inner layer, that's called a buried via. Or I could get a via from here all the way down to here, which is a normal via. And then I can start using all those copper layers. Everybody happy with it? That's good. Excellent. So, the difference between a through-hole and a surface mount component, if I want to use a through-hole component, the resistor, I will put my resistor on here, and it will stick up on the board like that, and I'll have two legs, and I'll drill two holes all the way through here, all the way through here, and then I'll pass my pins through, right the way to the other side, and I solder them here. Through-hole technology, it's going through a hole. What's that? Surface mount technology, I'll stick my resistor here, and I solder it here, and I solder it here. No hole needed. Far cheaper, far quicker. It doesn't block any kind of copper that goes through any layer. And you will be hard pushed now to find any employer that will let you use through-hole components. Because it's too expensive, it's too time consuming, it just doesn't pay off. It's great for learning, but ultimately they're too fat. If you had a mobile phone that was all through-hole, it would be a briefcase. Yeah, it just doesn't work. So, we're clear now on through-hole and SMT. Now I'm going to give you some examples quickly of the sizes that you were looking at. So you're all using through-hole, and as you can see, they've all got these legs on. All different sizes. This is what we call an SO8, which is basically an 8-pin chip. Here's a typical capacitor, you know, two wires hanging off. Everything, different sizes. When you looked at a resistor, why did you have so many selections? These two resistors I've got here, exactly the same values in resistance, but different values for their wattage. Right? So the higher wattage one's typically bigger because they're dealing with much more heat, aren't they? Yeah, and so I need to tell Multisim, yeah, I've got a resistor there, it's a 1K resistor, but I've got so many different sizes. Multisim needs to know which one so that it can properly space the holes that need to be drilled in the PCB. Yeah, that's why it's important to know the size of the component you're putting down, and that's why Multisim cannot choose it for you. So, this happens with every single through-hole component, and there's a whole massive selection. I mean, look at that, that's also a resistor, but that is no way going to fit in the same hole that we've done for one of these, is it? It's just, yeah? So it's really important that we get used to that. Now, when we move on to surface mount, things get a lot more interesting. So this is a typical example of a surface mount electrolytic capacitor, but there's just two pads on the bottom. So what's going to happen there is it's going to sit on the board like this, and how that will work is there will be what we call a shim, or a stencil. And when they produce the PCB, it generates a stencil that is a piece of aluminium typically, and they've cut holes in exactly where you expect to see these surface mount pins. And then this stencil is put over the PCB, and solder paste is pushed through these holes, and it leaves tiny little bits of solder paste on everywhere where there's expected to be a leg to be soldered. These are gently placed on top of the PCB, and then once they're all placed, it's passed through a reflow oven that heats up the solder, and then the whole lot reflows in one hit. Yeah, so no hand soldering needed. There is only one technology that can help productionize through holes, i.e. so we don't have to have a hand and a soldering iron, and that's called wave soldering. And you end up with a big tub of solder that's kept really hot and molten, and then the board will pass through it, and there will be waves generated in this molten solder, and the waves will flow over the board, and then when it comes out, all these through-hole pins are soldered. Really expensive to produce a through-hole board. Yeah. Okay, so we'll give you an example of some of the sizes. Now, in resistors, in surface mount footprints, we typically use the values of the size. So, if I give you some examples of some resistors, let's say this is a surface mount resistor. Right, okay, so we could say, right, that this is at 0804, 0603, 04, 02, 02, 01. What that means is 0804 is a standard foot pinch size, and it means I've got 8 mil here and 4 mil here. Yeah? So an 0201 means this component is 2 mil here, 1 mil here, and it does exist. Yeah? And it's if you're an experienced solderer, it's as small as you can go with your hands and a microscope. Anything lower than that, forget it. I normally very rarely get to work on 0201 because they're so small, and I have honestly been in this situation where I've been holding the component, soldering it, wondering why it's not soldering it, and then realised I've actually picked up a bit of dirt and not the component, and I'm trying to solder a bit of dirt on. It's that small. There is another, there is a 01005 that's just coming out. It's a high technology at the moment, and the reason why it's all there is because mobile phones, everything getting smaller, we're all pushing for smaller components to make it more efficient and tidier, yeah? So this is the same for capacitors as well, unless it's a tantalum capacitor. So the same for passive capacitors. They'll all use this type of footprint. And you'll also have bigger ones as well. You might get an 01206, you know, or 126 or a 2412 or something like that. Typically, the bigger they are, the older they are. Everybody now likes to work in 0603 or 0402. That's the most common by far. 0603 is really nice to work with on hand. It's just the right size. 0402 is a little bit stressy. 0201 is quite nasty. So this is an example. This one is an 0804. Yeah? And it comes on this reel, which gets fed through a pick and place machine, and it automatically pulls that off, it picks it up, and places it on the board ready for reflow. 0804. Other examples are, we have a bunch of surface mount regulators here, as you can see. So they've got a bit on the back and a couple of legs. Again, you can see it just needs to sit on the board and be reflowed. Yeah? And then finally, just to give you an example, this will be an example of an IC in here. Just have to open this one up. If there are actually any in there. I don't know if there are. There they are. Okay. You got a key or something?
Mike, lucky you didn't ask for a piano.